Hi everyone, I'm Mary with Mary Greeley News. Thank you for joining me. Well, there was a magnitude 5.1 earthquake this morning near Magma, Nevada. 36 people supposedly reported feeling this earthquake on USGS. 8.7 kilometers in depth, which would be almost 5.5 miles below sea level. All earthquakes are measured from sea level. 36 people reported feeling this earthquake. Here we have near Elk Grove, one there. Yosemite National Park, one there. Another one from Yosemite. Yeah, I wonder if they had rock slides. Mammoth Lakes, one. Near Owens Lake, this is Bishop, one. And Big Pine, one. Now this is all part going up through here, the Walker Lane rift zone or fault zone. It's a new fault zone that's being developed. One day it'll probably have one massive earthquake. Hopefully that doesn't happen, where it rips from the Salton Sea going all the way up. The Walker Lane takes about 20% of the stress from the St. Andreas fault zone. Eventually the Walker Lane will become the major fault zone, and the St. Andreas won't. Here is the location that USGS says it was. EMSC said it was a 4.1, and they give its location a little bit further north. So far, there is only one felt report on EMSC. They were 161 kilometers northwest from where this occurred. So that was Fallon, Nevada, about 100 miles away from where this occurred. And they said that they felt it themselves, and the water bottle on the table vibrated. So where's Fallon, Nevada? Let's do a search here. Oh, way up north. There we go. There's Fallon. And let's zoom out so you can see where this earthquake occurred. Down here. Fallon, Nevada. And the earthquakes occurred down here. I say earthquakes. There might have been two of them, both at the same time, but USGS isn't reporting the one. And the reason I say that is because, the distance that they have between them. Yeah, that's pretty significant. Usually they have them closer together. When EMSC reports one location and USGS reports another, they're usually closer together than this. So let's zoom out using Google Earth, and we're going to come down to Coso. This is an area of spreading. Let's see. Let me come down. There we go. Down here. Yesterday, I spent the time measuring or plotting out some of the old mines that were in the Owens Lake area when they had that large earthquake, which was at least a magnitude 8, maybe an 8.2 back in 1872. And I didn't mark all the mines that were located in that area. But there was a lot of people that were killed during that 1872 earthquake that were prospecting. And if you come over here, we got the Queen Elizabeth Prospect Mine. I think that means they were panning. We got the Sierra Gold Prospect Mine. There was also the Washington Gold Prospect Mine. And there was some more off on the east. But a lot of them were lead and uranium mining that was going on. I wonder if the uranium was used in glass back then. I don't know. I mean, they definitely were not using it for nuclear material. So the only thing I can figure is maybe glass. Sometimes you can find leaded glass with uranium that will glow under a black light because it's got the uranium in it. And they're often green glass you can find at the thrift shop, or white. I have one goblet that I found that I purchased at a thrift store. Maybe it was used on the dials of clocks to make the clocks glow in the dark. I don't know. Maybe some of you know more about that than I do. Also today in this area, USGS has a 2.8. Same location, a 2.5. Now that first one was 7 kilometers in depth. This was 10. A 2.9 after the 5.1. Prior to that, there was a 2.7 and a 2.5. And I've talked about, that's all they got for today. I've talked about how this area, the fault line that goes through here, is also probably connected to the Mono Lakes. And because of tectonic plate movement, this hot spot is probably moving northeast. Yeah, we got the Indio craters. And more likely, they got lava flows, or not really lava flows, magma. As the hot spot moved through this area, they got magma that's still under the ground that was deposited as the hot spot moved up and towards the east. More likely basalt that was laid there, deposited there. After the eruptions. Someone had asked a question about the most recent volcanic eruption here in the United States, and that would be, in fact, Mono Lake. Those that follow me will remember that I had documented the different eruptions that had occurred. We got South Deadman Flow. Let me see if I got it on here, which was 600 years ago. Yeah, only 600 years ago. And I documented which volcanic areas erupted first. The second one was Obsidian Dome. And where's the third one? Oh, there it is. The third one was Glass Creek Flow. And then we had Deer Mountain Flow. They all basically erupted at about the same time. Yeah, and this was the last eruption. Let me see if I got that there. No, I got it there. Was recorded probably 1721 through 1850. That discussion came up because of craters of the moon. No, not on the moon. Over there by Yellowstone. And I think what happened there, the same thing is happening here. And we'll go over to craters of the moon. Now, as the Yellowstone hotspot moved up through the Snake River Plateau, it deposited magma that was not expelled, and that was basalt. Yeah, there's pockets of basalt still under the surface here. And the same thing is currently happening, and those of you that follow my reports at Yellowstone, the same thing is happening right now at Yellowstone, where the magma is moving horizontally. It can't break through because there's a cap of rhyolite, and so the magma is slowly moving horizontally and depositing different fields of basalt. And about 15,000 years ago, some of that basalt came up in this one area, which I've talked about, that they were only recently discovered when they were surveying for a road going up to Mammoth Hot Springs. Yeah, they got different areas where they got obsidian, and let me zoom into this one small volcanic cone. Yeah, they didn't even know it was here, these volcanic cones, until they were surveying for a road. But anyways, it's not just rhyolite that they have that's being deposited. There's also basalt. Yeah, and other types of crystals that come up from deep within the earth, etc. But anyways, As these volcanic hotspots slowly move with the movement, well, they don't move, they stay in the same place. But as the continent moves, the upper crust of the earth slowly moves. It's laying deposits of magma under the surface of the earth, and that's still there, and every so often, yeah, something triggers it, an earthquake maybe, the pressure from the fault lines heating it up, and that magma then comes up. Not from an eruption from the caldera, from the plume of the earth, but because the pockets of magma, basalt, etc., has been heated. Yeah, and it comes up. I mean, it's just common sense that will tell you that. But they know for a fact, like off the coast of the United States, where we have subsidence. This is where all these volcanoes, the mountains, were built up because as the magma moves under the ground, yeah, and it gets stuck between the fault zones. The crushing effect, and then the heat of that compression, because it's being compressed, will cause the magma to come up. You can do a Google search, and here we see there on the ocean, the lithosphere, yeah, the little pockets of magma, and as it comes down, and yeah, then it comes up. They also have another example here, showing the layer of fluids that are deposited as this hot spot slowly moves. Well, I keep saying the hot spot moves. The hot spot doesn't move. The continents move. The hot spot stays in the same place. But as it moves across, it leaves behind, yeah, pockets of magma. Yeah, that magma doesn't constantly go up and subside as the continents move, you know, as you go across. Yeah, you got these pockets. Like I said, it's just common sense. Do a Google search on what types of magma does Yellowstone have. It is either rhyolite or basalt. They got both there. The higher the silica is in the magma of a volcano, the more explosive it is. Silica is crystals. It's found in larger quantities in granite. The upper pockets of magma there at Yellowstone is rhyolite. They figure it's between 5 and 15%. Where the deeper magma reservoir is basalt, and that's lower silica type. I know I'm a little off track, or you think I'm a little off track about this earthquake there in Magma, but here's an example. The upper lava dome, the cap of rhyolite, and then down here we have the basalt that is rising. Only, I believe it was last year that they found out that granite actually melts at a lower temperature than what they thought before. They thought it had to be a much higher temperature. And I only mention that because the rhyolite has a lot of silica, which you'll find in granite. Now, when I'm talking about pockets of melt, think of a sponge. And the holes in a sponge are the different types of rock. And not all rock melts at the same temperature. You know, as the heat comes up, yeah, it slowly rises and melts these little pockets of melt. Basalt melts at a temperature of about 984 to 1000 or 1260 degrees. I don't know if this has been updated, but here it says for granite is 1215 to 1260 degrees or Celsius, or 2219 or 2300 degrees Fahrenheit. That's the melting point for granite, which, yeah. All right, maybe this will make it simpler. We got basalt temperature, 1000 degrees to 1250 degrees. Rhyolite, 700 to 900 Celsius, or 1300 to 1700 degrees Fahrenheit, or for basalt 1850 to 2300 degrees Fahrenheit. And all these rock types are found there at Craters of the Moon, Yellowstone, and there at Mono Lake, Long Valley Caldera. Yeah, I haven't looked up how much rhyolite is at Long Valley Caldera or there at Mono Lake. I have not done the research to find out exactly if Long Valley Caldera has more rhyolite than, say, Yellowstone. And the higher the rhyolite content, the more, or I should say the silica content, the more explosive the volcano is. Anyways, that's all I have for you right now. If any thoughts or comments or questions, please put it down below. Thank you for watching. Please stay safe. Always be prepared for a disaster. Maybe it's a good thing we're buying masks right now for the coronavirus, because those also could be used during a volcanic eruption for ash. And ash has glass particles that will not cough out of your lungs. Once they're embedded in your lung, it ends up being like cement inside your lungs, and yeah, you end up suffocating. Yeah, I'm full of all kinds of good news information, right? Yeah, being sarcastic. Anyways, put your questions down below. Thank you for watching. Thank you for subscribing. Thank you very much to everyone for your support. You know who you are. And I'll talk to you later. God bless y'all. Bye.